To design a one-path algorithm to transform infix to a postfix, we have two observations. Okay. First one, let's check these examples. Given this a plus b times c, then if we use this parentheses approach, then we can have parentheses with b times c, okay, and then move this plus and the star, okay. So we get a, b, c star plus, okay. But also, we can read this as a recursive fashion, okay. So b times c is kind of one operand, okay. So a plus something, right? So b times c is kind of a sub-expression, so we actually transform b times c to bc star. Okay, and then we can look at this expression as a plus something. So a plus something will be a something plus, right? So recursively we can understand these things. And in the second expressions, a times b plus c, again it looks like a recursive interpretation is helpful. Okay. But anyway, with these examples, then we can get some clues. First one, the order of operands is the same in the infix and the postfix notations, as I said a couple of times. Okay, so just output operands without any rearrangement. So if whenever we see an operand, then we just pass that operand to the postfix notations without any rearrangement. Okay, and the second one, the order of operators in the postfix notation depends on the precedence of the operator. It means it depends on the order of evaluations. Okay, so operators with the higher precedence must be output before those with the lower precedence. So when we check this star and the plus, star goes first, right? Then star is higher in the precedence order. So star is higher, it means star goes first. So look at this first example, a plus b star c. So since the star is the first operator to be evaluated, then star is before the plus operator. Okay. So in the second examples, likewise, star is before the plus. Okay. So in this case, actually, star is before c and the plus. Okay, so that's a kind of clue. Okay, and each operator should directly follow its operands. That's another important thing. Okay, so all the operators should follow its operands. Look at this one, a star b. Then when we translate, it should be a b star. So star is following the a b. And look at the first example, a plus b times c. Okay, b times c is kind of operand. Okay, so it is actually a plus something. Then plus should be right after this a something. Okay, so it is following the operand actually. Operand, in this case, operand is one expression though. Okay, that's it. Now let's think about an algorithm to translate an infix to a postfix using HTAG. Okay, so basically, if the current place of current operator is not known yet, then push the current operator. It means we will push the current operator when the operands are not concluded. Let's take a look at this example on this slide. Input is a plus b times c. Okay, then remember, the order of operands does not change. Okay, so when we have an infix notations, infix expressions, then we will go through from the first token to the last token. Okay, the tokens include the operands and operator. So when we meet an operand, okay, something like a and b and c, So whenever we meet an operand, then we just copy that to the output. So this output is supposed to be a postfix notation for the infix notation. So we just copy all the operands because we don't change the order. And the operators are problems. Okay, so whenever we meet an operator, then we have to think about it. So the two operands are already determined. Then we can print it. Otherwise, we just push that into the stack. Okay, so in this example, A, when we meet A, then we just print out to the output, okay, and then when we meet the plus, okay, so we just push, okay, because we don't have previous operator and the right side is not determined yet. What if, as in this example, what if we have multiplications? Then plus is not the first operator, okay? The multiplication should be done before the plus operator, okay? So we don't know yet. If it is like A plus B plus C, then we have to evaluate A plus B first, okay? So it means when we meet the plus operator, then we don't know yet. So we will push that into the stack. And now we meet the B. Okay, B is an operand, so we just print out. And then now we meet the star. Okay, then think about this one. So when we meet the star, then we have to push, right? Because right hand operand is not fixed, not concluded yet. So we push the star. Okay, and then we print out C. Now we don't have anything, then we pop one operator from the stack, so which is a star, and then we don't have anything, then we pop the plus operator from the stack. That's why the output will be A, B, C star plus. Okay, simple. Then what about the other order, like A star B plus C? Then we will talk about it in the next slide. Okay. And the rules look complicated, but remember, only push only a higher operator than the top operator. So in this case, the star is higher than the plus, so we push. Okay. If it is A star B plus C, okay, then when we meet the star, we'll talk about it in the next slide, but let me tell you the brief ideas. If it is A star B plus C, then we push star first, and then we meet the plus, okay, then the plus is lower than the star, okay, then we will pop the star, and then we push the plus. So remember, the rule says push on your higher operator than the top operator. That's the only rule. Okay, and if the correct place of an operator is found, then print it. Okay, so when we scan the scan pointer reaches the end of the string, it means we are done with the strings. We are at the end of the string. Then places of all the saved operators are determined. So we will pop the operators and we just print. Okay, and the previous operator in the stack precedes the current operator. It means we have something like this A star B plus C. Okay, so when we meet the star, then definitely we push because we don't know the right side. Okay, so actually we might have some parentheses or whatever, we don't know. So we just push. And then we print out B, and then we meet the plus. Okay, so we want to push this plus, but when we check the top operator of the stack, it is a star, and star is higher than the plus. So instead of pushing a plus, we will pop first. So we will pop the star operator and then print out. And then we push the we push the plus operator. And then we print out C, And then we are done. So then we pop one operator at a time from the stack and we print out. That's how we can get A, B star, C plus. Now let's try an example. Okay, we have A plus B times C as infix notation, and we want to transform this infix notation to the post-infix notation, which is A, B, C star plus. Okay, so how can we get this one with the stack? Okay, to us it's really easy, but to computer we have to specify all the operations, all the directions, instructions, step by step. So when we first of all we can get all the tokens. Okay, so let's assume that, and then so we will look at one token at a time from the input expression. So we have A, so which is an operand, so we just print out into the output expression, and then when we meet the plus, then we push that operator into the stack. Now still in the output we have only A. Then next we meet B. So B is an operand, so we just print it out. Okay, then in the output we have AB. Next, when we meet the star, which is higher than the plus, so we just push. Okay, and then in the output we still have only AB. And next we meet the C. Then in the output we have ABC. And the last, we meet the end of sentence or end of string. Then we have to pop all the operators from the stack. Okay, so first one is a star, so we print out AB star. And next one is a plus, so we print out plus. So we have ABC star plus. That's how it works. Okay, so this is it. And there's a challenging problem. What if the current operator's precedence is the same with that of the previous operator? Then we will follow the association rule. So as I said before, when we push only when the current operator is higher than the top operator, then we will push. If we have a plus and plus, then we shouldn't push that, because the top operator is kind of higher based on this association rule, right? The top operator is actually on the left side of this current operator, and in the association rule it says the left operator should be evaluated first. Do you remember that? Okay, we have association rule. So left operator, when we have the same precedence with the different operators, then the left operator should be evaluated first. So it's kind of higher. So the right one is not higher. So we cannot push that operator, the current operator, into the stack. So if we have a plus plus, like A plus B plus C, then let's try A plus B plus C with the stack. So we have A, print out, then plus, push, okay, then B, okay, A. Now we have AB, and in the stack we have only one plus. Now we meet the second plus, okay, then the second plus is not higher than the plus in the stack. So we have to pop that plus operator. Okay, now we have AB plus, and then we push the second plus into the stack. So now we have, in the output we have AB plus, and in the stack we have plus. And we meet the C, so now we have AB plus C, and we meet end of sentence, end of string, then we have to pop everything from the stack. So we have AB plus C plus. Is it clear? Okay. So here are two examples. Transfer the following infix notations into postfix notations with a stack. Okay, so we have A plus B times C times D plus E. Okay, so let me go through this really quickly. Okay, so if you missed, then you can rewind. Okay, so A, in the output, it is A, and then plus will go into the stack, and then B will be in the output, and the star will go into the stack, and C is in the output, and star is not higher than the star in the stack. So we will pop the star from the stack, we print out. So now we have A, B, C star, and the second star will be pushed into the stack. And then we print D, and we have a plus, and plus is not higher, so we pop the star. So we print out A, B, C star, D star. Okay, and then this the second plus is not higher than the first plus. Okay, so we have to pop the first plus. So now we have A, B, C star, D star, and the first first plus. Okay, now we have a second plus in the stack, so we meet E. So we have A, B star, A, B, C star, D star, and plus E. Now we pop plus, so now we have plus at the end of this postfix notation. Okay. Okay, next we have A slash B minus C plus etc. So in this case, we push in the output we have A, and we push slash. Okay, and then in the output we have A B, and the minus is not higher than slash, so we pop the slash. So we have A B slash, and we have a minus in the stack, and then we meet C, so we have A B slash C, and the plus is not higher than the minus, so we pop minus, and then we push plus. So we have A B slash C minus, and D E star. And let me go through real quick. A B slash C minus D E star plus A C star minus. That's the answer. Okay, so if you know the rule, then it's not that complicated. It's kind of straightforward. Okay. Okay, this is the last one to implement a calculator. Okay. So what about the parentheses? So we have a parenthesis in the expression, then the parenthesis overrides everything, right? So it changes the orders of the evaluations, right? So as I said in the previous slide, one of the previous slide, we will look at this one as kind of recursive fashions. Okay, so if we meet the left parenthesis, then until we meet the right parenthesis, this is kind of, we will focus on these sub-expressions. Okay, so we will finish these sub-expressions, and then we will consider this one as one operand. Okay, that's basic idea here. Okay, so when we meet a left parenthesis, then so we have to check. Okay, so we will start a sub-expression here. So we will use the same stack. Okay, so to mark, we just push the left parenthesis. Okay, and it means until we meet the right parenthesis. If we meet the right parenthesis, it's kind of the end of string, end of the substring. Okay, so if we meet the right parenthesis, it's a conclusion of an operand in the parenthesis. Okay, so when we meet the right parenthesis, we will pop and print all the operators in the stack up to the left parenthesis. It means if we meet the right parenthesis, is the end of the substring. So we will finish all of them right before the left parenthesis. So left parenthesis is in the stack. So until we meet the left parenthesis, we will pop everything. Okay. Still, even when we have a parenthesis, we don't change the order of operands. So the same rule goes here too. So if we meet the operands, then we just print out to the output as a postfix notations. And whenever we meet operators, then we follow the previous rule, and we have another rule here. If we meet the left parenthesis, we just push, and when we meet the right parenthesis, then we will pop everything until we meet the left parenthesis. That's it. Okay, so we have one example here: A times parenthesis B plus C parenthesis divided by D. Okay, So let's assume that our tokenizer is working perfectly, and let's try to translate. So when we meet A, we just print out, perfect. Next, star, okay. So this is the first operator, we just push. Next, we have left parenthesis, okay, just push, okay. No hesitation, just push the left parenthesis. And then we meet the B, okay, so B is an operand, so just print out, no worry, okay, print out. And next, we meet plus, okay, so plus is not higher than star, but we have safe net here. We have the left parenthesis. Left parenthesis is kind of, we are starting a new stack, okay? So we don't just compare this plus with the star, okay? If we have left parenthesis, it means we will finish this parenthesis first, no matter what happens outside, okay? We will finish this one. So if we have a left parenthesis, we don't have to worry about anything before this left parenthesis. So in this case, the current operator is plus and the previous operator is star, but we don't compare these two. We will just check the right before. We just check the top operator. In this case, it's not operator, but this is the left parenthesis. Okay, so when we have an operator and the top operator from the stack is left parenthesis, no worry, just push. Okay, so we push plus. And then we meet the C, okay, then we just print. So now in the output we have ABC. Next we have a right parenthesis. Right parenthesis is the end of the substring. So we will pop all of them until we meet the left parenthesis. We just pop plus. So now in the output we have ABC plus. And then the left parenthesis is out. Then we just ignore that after popping. After popping the left parenthesis, we just ignore that. Okay, we are good. So in the output, we have ABC plus, and then next input token is slash. Okay, then slash. Slash is not higher than the star. Okay, so we pop the star, so we print out. So now we have ABC plus a star, and then slash will be in the stack. Okay, next we meet the D, we just print out, and we meet end of string, so we pop everything. So now we have ABC plus star D slash. Okay, this is it. So now we can implement our calculator from the infix notation to the result. Okay, good. So now we have two examples in the infix notation with lots of parentheses. Okay, so now transfer the following infix notation into postfix notations with a stack. Okay, so you can use a stack and you can try this one step by step. Okay, but let me go through this really quickly and let me give you the answer. Okay, we have lots of parentheses. And remember, we don't change the order of operands. Okay, so now, okay, A, then B, and C minus D plus slash, E, A minus star, C star. That's the answer. Okay, so don't change the operands and focus on the order of evaluation. Then you can easily translate. But when you implement, then computer is not as smart as us. Okay, so you have to give all the instructions step by step. Okay, next one. A, B slash C D star minus E slash F plus G minus. Okay, that's the answer. Okay. And the last topic of this chapter is a little advanced, so I'll give you just a brief idea about multiple stacks and multiple queues. Okay, sometimes we might need multiple stacks and multiple queues. Okay, so basically stacks and queues are quite similar to each other. So let's talk about just multiple stacks. Okay, so we want to implement multiple stacks in a single array. Then we have we have to divide the array into n segments. So look at this figure. So we have one single array. Then now we want to implement n stacks. Then actually we have to have n segments like this. Then we have to keep all the boundary informations. Where is the boundary? And then we have to have all the top indexes, right? So in this case, we need n top indexes, and we need n boundaries. Okay. So if when the one stack is full, then we have to reorganize the memory. Let's say the first stack is full, but the other stacks are empty, then we can reorganize the memory space, right? When we have only two stacks, then that's much simpler, because stack grows from the left side. The first stack grows from the left side to the right side, and the second stack can grow from the right side to the left side. So we don't have to reorganize the memory, right? So as long as we have some empty space, then we can enjoy two stacks without any reorganizations or some things. Okay, that's the end of this chapter. Okay, you did a great job, and we've been through two main data structures, stack and queues, which are really popular in the computer science. Okay, so I hope you understand all the sample codes and you can finish the homework assignments. Good.